Another example, v is the span of two functions, cosine of t and sine of t. So these trigonometric functions are used in numerical methods many times. And we look at it over the scalar field of real numbers. Then we define T as a linear mapping from V to V. So the notation was L of V when we map from V into V. This is defined by T of f of t equals to the second derivative of the function plus 9 times the first derivative of the function plus 5 times the function. We talked about the derivative as a linear operation. Second derivative is also linear, addition is linear, and scalar multiplication is linear. So it's easy to see that this is a linear transformation. And we would like to know the matrix of T in the basis of cosine T, sine T. So again, this is kind of fantastic that we're going to differentiate using just a matrix vector multiplication. So the definition is that we just collect together the transformation applied to the basis elements one by one. So T is the second derivative of cosine, that's minus cosine of T, plus 9 times the first derivative is minus sine of minus 9 sine of t, and then 5 times the function, so that's 5 times cosine t. And we will need the coordinate matrix of this in basis B. We use the bracket for the coordinate matrix. Then t applied to the sine function, the second derivative of sine is minus sine, because sine, cosine, minus sine. Then plus 9 times cosine of t, plus 5 times sine of t. And again in the B basis. So we have some simplification here. Minus cosine plus 5, that's 4 cosine of t, minus 9 sine of t. Again, we will need this in the B basis. Then here we have 4 sine of t and 9 cosine of t, and this is in the B basis. So in the B basis, the basis is cosine t and sine of t. So this will be a vector with 4, that stands for the multiplier of cosine, and minus 9, that stands for the multiplier of sine. Then the second column, cosine has multiplier 9, and again sine has multiplier 4. So this is the A matrix. And again, the reason why this is so fantastic, because if you, for example, want to apply this differential operator, second derivative plus 9 times the first derivative plus 5 f of t. For example, a function like 3 cosine of t minus 2 sine of t. Instead of doing all this differentiation, all you have to do is multiply the 4, 9, minus 9, 4 matrix with the coordinate matrix of this function, which is 3 and minus 2. And what we get is 12 minus 18, that's minus 6, and minus 27, minus 8, minus 35. Now this column vector doesn't make much sense right now, because what we calculated is just the coordinate matrix of the result. So in fact, if you want to get the actual result of this differentiation, then we have to multiply this coordinate matrix from the left with the basis. So what we get is then minus 6 cosine of t minus 35 sine of t. And this is kind of faster than differentiating twice and adding together things. And the idea is that matrix vector multiplication can be done on the computer. So typically what people do in numerical methods is that they have not just cosine and sine, but they have hundreds of these functions that can be used to approximate a function with cosine and sine. And then they have much bigger matrices and vectors to multiply together, but computers are fine with that.